Authored by veteran chemistry teacher Abdul Shakur, these two textbooks provide all the essentials that would not only enable students to master grade 11 chemistry, but to excel at the next higher level in this subject. What make these texts unique are their creativity and profundity with which concepts are explained for clarity and mastery. The following is one of a set of 44 different tutorials created by the author, using materials primarily from the text Chemistry 11 in Focus. I hope you enjoyed this video. If you liked it, please give it a thumbs up and don't forget to subscribe. We will see you in the next video and thank you for watching.
Our lesson today deals with the atmosphere, the nitrogen and carbon cycles. We'll be talking first about the formation of the atmosphere, composition of the atmosphere, and then the nitrogen and carbon cycles. But before we go any further, I just want to pay tribute to our beloved Earth. Our planet Earth is endowed with certain distinct features that make it the only habitable one known to scientists as of now. Tilted on its axis at an angle of 23.5 degrees and located at a distance neither too close nor far away from the sun, it enjoys a moderate average temperature that is supportive of various life forms. The two extremes of temperature caused by winter and summer, of course these are the two temperatures here, negative 65 degrees Celsius and 45 degrees, respectively, are not too severe to prevent organisms from adapting and thriving in both terrestrial and aquatic ecosystems. The tilting of its axis produces seasonal fluctuations that make possible the proliferation of living organisms over all parts of the Earth. Without this tilt, some parts of the Earth, the poles, will be in perpetual twilight. Of vital significance is the unique composition of our atmosphere. The presence of life-sustaining oxygen and carbon dioxide are two features that distinguish the Earth from other planets. Without oxygen, there will be no cellular respiration for energy production, and without carbon dioxide, there will be no photosynthesis for food production. Also, the presence of carbon dioxide and other greenhouse gases keep the Earth warm. Without these, everything would freeze. The presence of a thin layer of ozone, 3 millimeters thick if compressed, at a distance of 15 to 25 kilometers above sea level, blocks most of the dangerous UVB from reaching the Earth's surface. The rotation of the Earth not only causes day and night, but produces a strong magnetic field that extends outwards to about 65 kilometers, where it traps dangerous solar winds generated by the sun, preventing them from reaching the Earth, saving us from catastrophic consequences. Along with water, with its most unique physical and chemical properties, and an abundance of arable land, these endowments undoubtedly present us with an earthly paradise. What else could we ask for? Human beings and other organisms have lived and survived on the Earth for thousands of years. There's always been a harmonious balance between the activities of humans and the cycles of nature. However, as the human population grows, the need for more space and resources becomes important for survival. Humans have thus resorted to more deforestation and burning to clear space for more robust agriculture and habitation. The need for more transportation has seen a rapid proliferation of motor vehicles and aircrafts, etc., that work by the combustion of fossil fuels. Other types of industrial and technological revolutions have resulted in the manufacture of various types of new products and chemical compounds. Many of these inadvertently enter our environment, thereby polluting it. The following sections will examine how human activities are having profound destructive effects on our environment. These effects include global warming, acid precipitation, ground level ozone problems, and ozone layer depletion. There is growing evidence that global warming presents the most dangerous existential threat that is causing climate change with catastrophic consequences. To save our planet from these ecological disasters, everyone needs to make concerted efforts to restore and maintain our environment to states that are life sustainable. So we then proceed to talk about the formation of the atmosphere. So I've collected some information and I've written this paragraph here that gives a brief history of the formation of the atmosphere. I'm giving you a few minutes to read that. Then we look at the figures that follow, which will help to illustrate these points. Okay, we'll now go and examine these figures here that will make clear these points that have been mentioned there. So this figure here tries to depict what the atmosphere was 4.5 billion years ago. So scientists believe that there were violent volcanic eruptions, and during that time, two types of gases were produced: helium and hydrogen. Both of these being very light, it is believed that they escape into space. However, it is believed that with subsequent volcanic eruptions, four different gases were produced, namely methane, ammonia, water, and carbon dioxide. However, with the subsequent cooling of the Earth, a number of changes with regards to the composition of those gases happen, and I just want to outline what these changes are. It said that with the cooling of the Earth, there was condensation of the water vapor that formed bodies such as oceans, lakes, rivers, etc. Also, with the formation of these bodies of water, it is said that much of the carbon dioxide diffused into them. Secondly, with the advent of plant life and photosynthesis, there's a continuous need for carbon dioxide, and that is why there's always been a constant diffusion of carbon dioxide into these bodies here. As a byproduct of photosynthesis, we all know that oxygen is produced, and that is why they said that oxygen gained ascendance in the atmosphere. So there was a decline, marked decline in the concentration of carbon dioxide and a profound increase in the concentration of oxygen. Another change that took place was the decomposition of ammonia gas with energy from the sunlight into hydrogen and nitrogen. Again, it is believed that the nitrogen, being very light, escaped into space. Outside there is space, nothing exists there. However, nitrogen, being very stable and much heavier, remained behind, and it is from since then it has remained the dominant gas, the most predominant gas in the atmosphere. Finally, it is believed that an ozone layer was created in a part of the atmosphere that's called the stratosphere. It is believed that oxygen molecules reacted with each other with energy provided by the sunlight to produce ozone molecules. So that was a brief history of the formation of the atmosphere. It is believed that there were violent volcanic eruptions that produces these light gases here, and these quickly escape into space. Subsequently, there are more eruptions that produce four different gases: methane, water, ammonia, and carbon dioxide. Subsequent cooling of the Earth resulted in most of the water vapor condensing to form lakes and oceans and other bodies of water. With that, carbon dioxide from the atmosphere diffuse into these bodies here. Of course, with the advent of plant life and photosynthesis, oxygen was produced, and that became another dominant gas there. And then you had the decomposition ammonia to produce hydrogen. Hydrogen escaped into space, and this guy stayed back and has remained the most predominant gas. And finally, with energy from the sunlight, oxygen molecules reacted to form this ozone layer. Of course, we know this ozone blocks lots of UV from reaching the surface of the Earth. So this table here and this pie chart here show us the percentage composition of each gas by volume. Here you can see nitrogen is 78.08%. It is a triple bonded molecule, and this is of significance to us as we'll be talking about the nitrogen cycle. This triple bonded nature of the nitrogen molecule dictates some of the events that happen in the nitrogen cycle. And of course, this is oxygen here. These two gases combined alone account for about 99% of what is present in the atmosphere. Then you have argon here. Look how small this value is for carbon dioxide. Yet this is of concern to us. Why? Because any small rise in this concentration here is posing a headache for us, as is happening right now because of the billions of tons of carbon dioxide that are being produced by burning of fossil fuels, and that is associated with global warming, and we know the consequences of global warming. And then you have all these other gases there in very small concentration here. And here you have the pie chart that depicts the same thing that is you're seeing here. Okay? So next time we talk about the nitrogen and the carbon cycles.